Alright everyone, let's change course and talk about how we can simplify radical expressions. Hopefully most of this is a review, but if it's not, stay tuned for some great stuff. So, perfect squares. 2 squared. Very simple. 2 times 2. Very easy. Nice 4. 3 squared. 9. 4 squared. 16. 5 squared. 25. Now what if we wanted to do the opposite, as in the inverse of a perfect square? We would have the square root of 4. So the square root of 4 simplifies to plus or minus 2, while the square root of 9 simplifies to plus or minus 3. Now before I move on, you might have questions as to why it's plus or minus. Well, let's take a look. There are two ways that I can square a number to reach 4. I have negative 2 squared, which is 4, and 2 squared. That gives me 4. So we must account for both positive and negative squares. So to continue, the square root of 16 is equal to plus or minus 4. The square root of 25 is equal to plus or minus 5. The exact same thing that we started with. Right here. So the inverse for any number squared is the square root. So let's figure out some properties to help us simplify radical expressions. So here I have the product property of square roots, which states that if I have a product under a radicand, the square root of 9 times 5 is equal to the square root of 9 times the square root of 5. The reason why this is important is because I can simplify it this way. The square root of 9 we now know is 3. The square root of 5 is an irrational number, so I leave it alone, and it simplifies to 3 times the square root of 5. In the general case, the square root of a times b is equal to the square root of a times the square root of b, so long that a and b are greater than or equal to 0. We're going to get to more about why this must be true. But before we begin, let's use the property that we just learned here. The square root of 25, very easy. We know that it's 5. The square root of 8 is not a perfect square, so I must break it up as the square root of 4 times the square root of 2. And based on the property that we just learned, we have the square root of 4 times the square root of 2, which simplifies to 2 times the square root of 2. One more time. I have the square root of 27. Again, I can't take the square root of that, so I need to break it up. We have 9 times 3. Then that leads me to the square root of 9 times the square root of 3. And the square root of 9 is 3. And the square root of 3 is an irrational number again. We leave it. And so now I have 3 times the square root of 3 as my fully simplified expression. Here. Now what if we have some negative numbers? Well, let's take a look. The square root of 25, again, we know it's 5. However, we have the square root of negative 25. Now you might think that it's negative 5. However, extremely incorrect. Now let's discuss why. So, we know that a perfect square is a numbered square. I have 5 squared, which is 25. This checks. However, if I were to substitute a negative 5 and took the perfect square of negative 25, I would get negative 5 times negative 5, which gives me a positive 25. And this is where the problem lies. My solution is a positive 25. However, I'm asking you to take the square root of negative 25. It is impossible for me to square any negative number, and receive a negative number in return. This is called an imaginary number that you will learn more about in Algebra 2. The one case that you can do is this last one. If you see here, I have negative the square root of 25. And as you just learned, I can take the square root of a positive number. And the negative is simply negative 1 times the square root of 25. Which now, that negative 1, we know the square root of 25 is 5. So negative 1 times 5 is negative 5. Let's do one more. Negative the square root of 16 is equal to negative 1 times 4. So 4. Negative 4, excuse me. Great. Now, what happens when I have variables? Well, there's many different ways that you can understand this. And the first one is the square root is the inverse of a numbered square. So, the inverse, this square root essentially reverses that number squared, or in this case, x squared, resulting in x to the 1 power, or simply x. The second way, if you remember back into our exponential properties, we have the square root of x squared. I can rewrite the square root as x squared to the 1/2 power. Using the power of a power property, I have x squared times 1/2, which is 2 over 2, and again, giving me back to x to the 1 power, which is exactly x. Let's take a look at the square root of x to the 4th. Now this is a little different because it's raised to the 4th power. However, our very first property shows me that I can break this up as x squared times the square root of x squared. And I do know that the square root of x squared is equal to x, and the square root of x squared again is equal to x. So x times x is going to give me x squared. Looking at the square root of x cubed, I'm going to do the same thing. The square root of x squared times x is equal to the square root of x squared times the square root of x. And again, the square root of x squared is x times the square root of x. This is my answer. Now, the square root of x to the 6th power is a little different from our understanding. But if you can't see it automatically, let's break it up like we did the first 3 problems. So, I can do the square root of x to the 4th times x squared, because this is the same as x to the 6th power. And we're going to break this up again And I know from the second question that the square root of x to the fourth is x squared. And hey, look what happens. The square root of x squared, again, is x, resulting in x cubed. The reason why this works is you would have to think of the first example I gave you. We can rewrite the squared as x to the 1/2 power, x to the 6 to the 1/2 power, resulting in x to the 6 divided by 2, and again, x to the third. Two different ways of handling it, same outcome. Just using two different types of properties that we have learned over the year. Great. Now, let's simplify this. 108 isn't easy to see, so what you can start by doing, in order to find out a perfect square that is divisible by 108, try 108 divided by 4, 108 divided by 9, and so on. And in this case, 108 divided by 36 is 3, which means that 36 times 3 is equal to 108. And again, using the product property of square roots, I have the square root of 36 times 3, resulting in 6 times the square root of 3. Now, we're going to make things a little bit harder, but I promise you got this. So, the square root of 9 times x to the third can be rewritten as the square root of 9 times x squared times x. And again, I'm going to use the product property of square roots to get the square root of 9 times the square root of x squared times the square root of x, giving me 3x times the square root of x. Because the square root of 9 is 3, square root of x squared is x, and the square root of x is simply the square root of x. Now, I'd like you to try a few. Find the square root of 24. Now, simplify negative square root of 80. Now, simplify the square root of 49 times x cubed. And lastly, the square root of 75 times n to the 5th power. For number 1, you should have gotten 2 times the square root of 6. For number 2, negative 4 times the square root of 5. Number 3, 7x times the square root of x. And the last one involved a little bit more work. So what your first step should have been is to notice that 25 times 3 is 75. 25 is a perfect square, so I can break up the square root of 25 times the square root of 3. And n to the 5th can be broken up as you see there. So the next step is to take the square root of 25 and the square root of n to the 4th, which is 5 times the square root of 3 times n squared times the square root of n. Now to rearrange this, I would move everything outside of the radicand to the front and the rest to the back, as I did here. And I want to undo the product property, and I would get 5n squared times 3n as my final answer. Great, let's keep going. The quotient property of square roots. Very similar to the product. If I have the square root of a fraction, in this case 3/4, I can rewrite my expression as the square root of 3 divided by the square root of 4. The square root of 3 is an irrational number, hence why that is my answer. However, the square root of 4 is 2. So in the general case, for any real numbers a, b, the square root of a divided by b is equal to the square root of a divided by the square root of b, so long as a is greater than or equal to 0 and b is greater than 0. The reason why b can only be greater than is because if I had a 0 in my denominator, you'd know that I would have no solution because it would be impossible to start my division process that way. So now, some examples. Simplifying. The square root of 15 divided by 64 can be rewritten as the square root of 15 divided by the square root of 64. Now, the square root of 64 is 8. The square root of 15 is the square root of 15. So I'm done.